Hi, Tar. Thanks for that. Hope you all can see my screen.
Yeah.
Okay, great. Thank you. So let's start the session. So my name is Imesh. So I work for Google Cloud in Apigee team. So in today's session, so we are going to talk about Google Cloud Run. So to start with, so what is serverless computing? So as some of you may already know, so serverless computing is a cloud computing execution model where a cloud provider would provide computing services by dynamically managing the resources while bill based on the actual amount of resources consumed. So if we compare this with a standard computing model, so what happens is normally we allocate computing resources for a continuous time period, and then maybe sometimes these instances automatically scale based on the load. So then at a given time, it will run minimum number of instances, but we'll have to pay for the complete time period of compute instance usage. So if we compare this with a serverless model, what happens is at any given time, if the system is idle, it will try to bring down the instance count to 0. So that's a theoretical way of doing serverless computing. In real scenarios, we might need to run at least one or multiple instances to reduce the startup latency. So then the advantage is the user will only be billed for the actual compute time. So the running cost will be minimum with if we deploy an application using serverless computing model. So so in terms of operationals and programming models, so with this approach, the user doesn't need to manage the infrastructure. He doesn't need to manage other aspects of the solution, but rather the cloud provider, which provides the platform, will provide all that. And there are different programming models. So mainly you can implement systems with service-based components, event-driven systems, and many other types. So up to now, when the containerization movement grow, after when Kubernetes was introduced, and thereafter serverless framework started to develop. So from that point onwards, so initially serverless concept came with serverless functions. So even though it was not called as serverless, but even before serverless functions, this operation model was there with platform as a service solutions. So with serverless functions, what happens is we implement the deployment unit as a function, and we deploy a collection of functions on that platform. So then the main usage of that type is mostly for handling events triggered by cloud computing systems, and so on. So with the second approach, so you could deploy a complete application on a pass. So an example would be App Engine. So then you can directly take your source code and let the serverless application platform build it and deploy it by detecting the application runtime and required other configurations. So the user doesn't need to do the packaging for the deployment. So it will be done by the platform. So then the application deployment unit is the application or a component. So when it comes to serverless containers, the advantage is, so we can package our application or a component into a container and then let the platform run the container itself. So then we have the flexibility to package all dependencies and other required binaries and so forth into a container, verify the container first, and then let the serverless platform run the container itself. So in this model, why do we use containers? So the thing is, like, containers are lightweight, so they have a very low resource footprint. So then it's very easier for a serverless system to dynamically spin up a service with less time. And of course, there are other ecosystem benefits. So there are many base imagers and other tools available for building container imagers and a complete system using containers. So that's why mostly serverless systems use containers. So on GCP, there are three options for deploying applications in serverless mode. So Cloud Functions, App Engine, and Cloud Run. So Cloud Run is the latest offering GCP came up with. So mainly Cloud Functions can be used for lightweight, event-based applications to be implemented. Like, say, if we have any, like, a component listening to a pub/sub topic, or a cron job which is scheduled to run periodically. So those types of triggers can be handled by Cloud Functions. So as we discussed earlier, an application itself can be deployed on App Engine. So the main difference between App Engine and Cloud Run is that on App Engine, we provide the source code to App Engine to deploy. So then the compilation and the deployment is executed by App Engine and deployed on its own environment. So if there are any like deployment time issues caused due to dependencies or operating system versions and so forth, then it will only be detected at the deployment time. So with Cloud Run, so once a container is built, it's very unlikely that a deployment type of an error is raised at the runtime, because we could verify the container beforehand. So now let's go into Cloud Run. So these are the main three pillars of Cloud Run. So on GCP, you could build a application and push to production like with very less time. So it's built with native serverless features, which we'll talk later in this session. And it will give one experience either on the cloud or on-premise. Okay, so let's start with the demo. So if anyone has any questions up to now, please feel free to ask. So if you like, and if you have a GCP environment, you could also try this out while I'm going through the demos. So today we are going to cover 5 different demos. So first we'll see how we can implement a web application in Node.js and try to build that, and then create a Docker image for that, and then push it to Cloud Run. So later on, we'll check how to roll out updates for an existing application without causing a downtime. And we'll then check how we can run a load test against a Cloud Run application and see how that behaves and how performance latency is based on the load test. And afterwards, we'll go through how CI/CD can be set up using GitHub. And finally, we'll talk about how to implement a complex application where we could have multiple services communicating to each other. So then how we could implement authentication using service accounts on GCP. So, so this is the first demo. So here, let me first open the Cloud Shell. So here, what we're going to do is, so first we'll try to implement a simple server.js file and expose a HTTP endpoint. So in Cloud Shell, so if you're familiar, so this is provided for free on GCP. So you can use this to write code and maintain your code base. So here, let me quickly create a folder. So let's call this Cloud Run Hello. And let's create a server.js file. So I'll take this code. So in the terminal, you can access the same folder. So if you go to Cloud Run Hello, so we should see the server.js file. Now, if I try to run this, so in Cloud Shell, there's an option where you could connect to a socket open up on this shell. So using, that's called web preview. So here we can open up a public endpoint, which will tunnel that request to the Cloud Shell. So you could see, so that application is now working. So next, what you can do is we can quickly create a Docker file for this application. So so this is very simple. So we just use not base image with version 12 slim tag, and we add the server.js file and then just start it. So let's build the Docker image. Okay, so let's start it by opening up port, mapping port 8080 of the container to the port 8080 of the host. So now we could verify this again using the same web preview option. Yeah, so that also works. So here in the shell, you can see when we send a request from here. So you can see that's being printed on the shell. So now our container is good. So container image is good. So what we'll do is we'll now try to push this to the container registry. So I'll show you my GCP project. So I have a project called GDG Cloud Run, and I have ping 3 services: Cloud Run, Container Registry, and Cloud Build. So this is Cloud Run, and this is Cloud Build, and this is the Container Registry. So at the moment, I don't have any images in the container registry.
Imesh, I think something's wrong. We can't clearly see your screen. I think someone else started sharing and your...
Oh, really?
Yeah, your presentation went to the background.
Okay, let me check. How is it now? Let me check. I'm trying to present again. Let me know whether you can see my screen.
Yeah, I can now. Thanks.
Okay, great. Thank you. Okay, sorry about that. So now what we did was like we wrote a small Node.js web application, created a Docker file for that, and then build a Docker image and verify the Docker image. So the Docker image is working correctly. So now we're trying to switch to GCP container registry and push that image here. So to do that, so I'll first set my region and my project ID is this. And I'll first tag my container image, which I previously used. The tag is this. So I'm tagging it with the container registry path. So then we can use that to push the image to the proper registry. So now so we're executing Docker push with the container registry image path. Okay, so now if we go here, ideally it should have come here. Yeah, so you can now see we now have an image and it should also have a tag. So the next step is, so we could run a gcloud run deploy command, which is used for deploying a container image to Cloud Run. So I'll explain the command I'm using here. So here what we are doing is we are saying gcloud run deploy. The next parameter is the service name. And then we are saying use the managed version of Cloud Run. So, so that is hosted by Google. So then we specify the region. So I take the region to US East 1, and this is the image. And the final parameter, so this says open up the HTTP endpoint without authentication. So currently I don't have any services running on Cloud Run. So now with the command being executed, so it is creating a new service on Cloud Run and routing traffic, and it gave us an endpoint. So now if we try to access this, so you can see the web application we developed is now exposed through a public endpoint. So that's the process of deploying a container image to Cloud Run. So now we'll check how we could roll out an update to this application. say for an example, so currently if we go to the Server.js file, so the text is this. It just says hello world. So let's change this to hello world from Cloud Run. So and save the file and build the image again and push it to the same container registry. So one advantage of using the Cloud Shell is that so Cloud Shell connects to an instance on GCP itself. So the build time of an image is very less. So if you build it locally on a local machine, so the data should be transferred over the wire to Google Cloud. Yeah, so the image is built and pushed. So now if we go to the public URL, we should still see the previous text. So now if we redeploy, what would happen is it will create a new revision. So here, if we go to the Cloud Run service, you will see there's a tab called revisions. So every time we do a new deployment, it will create a new revision. So now we can see there are 2 revisions. So this should have been completed. Yeah. And if we go to the public URL and refresh, so now you see the updated text. So this process is very similar to App Engine. So, so the advantage of this is, like, say we do a new update rollout. If there's any issue, we can quickly switch back to the previous revision. So there's an option called Manage Traffic. So this is the latest revision. So now it's serving 100% traffic. We could say switch this back to previous revision. So that will happen without a downtime. So after a few seconds, it will switch back to the previous revision. And if we refresh here, you will see the previous version. So it's very seamless. Okay. So now let's try to run a load test against this. So to run the load test, so I'm using a separate platform called loader.io. So it allows us to talk to a target server and then generate a load. So if you go here, so to do that, first what we need to do is we need to create a target endpoint and verify that, because this doesn't allow us to generate a load to any endpoint. Basically, we need to authenticate and verify our endpoint, and then only it does allow us to generate a load. So to do that, so what we'll do is we'll get this endpoint from here. And edit in loader.io. And then it will generate a token for us. So now what it expects is, like, it expects us to generate, create a HTTP endpoint on our web host, so then it can verify it's owned by us. So to do that, so what I'll do is quickly update our server.js file. So in this, we'll add another API resource to handle this token endpoint. If we get a request to this path, it will return this value. So that is what they expect from here. So let's save this. And redeploy our application. Okay, that is done. And now let's execute a rollout. Okay, so if we now go to load.io, click on this link. Did I miss anything? We added this. Yeah, let me quickly check this here. Right. Okay, that's good. Pushing again. This is good. Oh, it's okay. So yeah, it's still serving from distribution. So let's switch traffic to latest one. Okay. So now if we check this, yeah, this is good. So now we can say verify. Okay, it's good. So let's create a test. So what we can do is yeah, we can run a test which will increase number of clients from 0 to 500, and which will run for around 30 seconds. So here you can see on the left side, it shows the latency, and on the right side, it shows the number of clients. So in green color, it shows the number of clients corresponding to the right side values. So you can see now the clients are increasing to around 400, and the latency, the average latency is around 50 milliseconds. Yeah, we could run it again for like around 1 minute. And here we can go back to the Cloud Run dashboard at the same time. So in this, under Matrix, you could see statistics of this service. So, so here you can see the request count, then the request latencies, and you could also see the billable content instance time. So this is how we get billed. And resource utilization, CPU, memory, so all that details can also be seen here. And we can also see logs. So you could see, since we have some console log statements, so we could see those here. So now this is how our Cloud Run service, the Hello World service, reacted to a load test. So, so the load test was generated from US East, and we also deployed the service in the same region. So initially you can see there's a slight spike in latency due to the warm up, and then it goes down to around 40 to 50 milliseconds. Yeah, let's go to the next demo. If you have any questions, feel free to stop and then ask any questions. So next, we'll see how we could do a CI/CD integration and automate this process. So to do that, so first, what I'll do is I'll create a new GitHub repository and add the code that we just wrote to the repo. So I'll use my GitHub repo for that. So let's create a new repository, say Run global. So what we'll do is we'll take this code. So we'll take it from here. Create a server.js file. Also create the Docker file. And then for cloud build, so if you go to GCP console, you'll see that there's a product called Cloud Build. So Cloud Build is a CI/CD system. So for us to trigger a build, it has its own build file format called Cloud Build YAML. So here what we do is we define steps. So if you can see here, like in the first step, we say by using this Docker command, execute build with these parameters. So similarly, run a Docker push as the second step. And finally, execute a gcloud command, gcloud run deploy with these parameters. So basically what we're doing is we are scripting what we manually did earlier using a cloud build YAML file. Yeah, this is good. So let's add that as well. Okay. So now what we can do is we can take the repository URL, go to Cloud Build, go to triggers. So at the moment, I don't have any triggers. So first we need to connect the repository. So under this UI, you can select the relevant source control system. So I'm using GitHub. And I have already authenticated my repository once. So therefore, it automatically populates all my repos here. So if we now say cloud run hello world, it will show us the new repository we just created. Then we can say connect repository and then create push trigger. So if we just check the dashboard at the moment, we don't have any builds running. So what we'll do is we'll manually trigger this build. So now you can see the build is running. And if we go to the details page, so you can see the build steps here. So first it's executing the Docker build, and then the Docker push, and finally it executes the gcloud run deploy command. And so if, yeah, so it executed properly, but it's saying it's not serving traffic. So this should be because if we go to Cloud Run, so we had the same application earlier. So yeah, let's try to delete this. Yeah, and trigger the build again. Okay, it worked. So now if we check this URL, yeah, so it's up and running. So if you go to Cloud Run Services, now we should see a new service here. And at the same time, if we go to the repository, yeah, it will also show the builds that we run here. So this, the first one failed, and the second one, we could see details here. Yeah. So that's how we could integrate CI/CD for Cloud Run using GitHub. So if we move forward, so if you're implementing a real-world application, generally, like we would have multiple components, right, within a single application. So in this demo, what I'm trying to show is like how we could have an internal component which is not exposed to the external network and only allow access to another internal component. So basically, so we have a web application talking to an API. So the API should only be accessed by the web application, which will provide a secure endpoint here. And the web application will open up an unsecure endpoint to let any user access the web application. So for this, I have already created two repos. So the web app and the API is already created. So in this demo, what we're trying to do is we are first going to create two service accounts. So if we don't create a service account for a Cloud Run application, it will use the default compute service account of the GCP account. So then it will have full access to the application. So let's first do this. So let's go to the Cloud Shell. 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 So let's go to the So I actually have created these service accounts already. So then when we execute this, you will see that it will say these service accounts are already there. So once the service accounts are created, we will attach the API project. So first we'll host the API project and find the API URL. That's because on Cloud Run, by default, it provides dynamic URLs. So to let the web application talk to the API, we need to configure the API endpoint in the web application. So to do that, let's first open the Cloud Run Hello API project. So here, if you open up the server.js, so this is a very simple server.js file, which returns a JSON response. That's all. So let's first deploy this on Cloud Run. So I take the GitHub repo URL, go to Cloud Build, go to triggers, connect this repository. Cloud Run Hello API. Create a push trigger. So Cloud Run Hello, this one, and let's trigger that. So in services, we don't have that at the moment. So once this build executes, so it should create a service. Yeah, so Docker build is completed. Now it's running the G-Cloud Run. Yeah, that's good. So now this is raising an error, HTTP 403 error. So that's because if we go to the Cloud Build YAML here, so you will see in this, we have specified a service account and also specified this parameter saying, do not allow unauthenticated access. So that's why this endpoint cannot be accessed from outside. So if you go to the demo, still, if you want to test this, so we have a way to invoke it. So what I can do is I can get this URL, go to the Cloud Shell. I can try to send a request to this endpoint. It should fail, basically, yeah. So we are getting a 403. So we can use gcloud auth print identity token command to obtain an access token. So this, what will happen is like, this will use the default compute service account and generate a token. So if I try to print the token, yeah, so we got a token. Now if we send a request with the token, okay, now it works. You can see that we are getting 200 response. So that's how we could test a secured endpoint. So now what I'll do is, so I'll take this endpoint URL and go to the web app repository. So in this, so we in the Cloud Build YAML file, we have defined an environment variable. So if you check here, so we can pass the API endpoint URL using an environment variable to the app. So I just added the latest URL and I'll commit this. So if we check the application implementation, so here what we are doing is, see, first, you can see we are using Google Auth library, got library for making HTTP request, and Google Auth library. So first we read the API endpoint URL, and we have a function written to talk to the API endpoint. So here what we are doing is, so here using the API endpoint URL fetch using the environment variable, we are obtaining an ID token, a Google Cloud ID token, and then using that, we are obtaining access token. So once an access token is fetched, so we use that to talk to the API endpoint. So let's try to deploy this. So we do the same. So we go to Cloud Build, create, so add this as a repository. Cloud Run Hello Web App. Yeah, this one. Create a trigger. So that should be this one, Cloud Run Hello Web App, and let's trigger that. Let's check services. At the moment, we only have two. The first Hello World and the API. So in this, we have 4 steps. So let me show you what those are. So, so we build the Docker image, and we after the build, we create a tag. So whenever we create a build, Cloud Build has environment variable called commit SHA. So it will give us the cloud the SHA value generated by the Docker build. So we read that using this environment variable and tag it as the latest tag of this image, and then push the latest to the container registry and then deploy. So now this is successful. So if we check the logs, yeah, it says serving 100% via this URL. Now this should also say forbidden. So that's because, so still we didn't grant web application permission to access the API. So that is expected. So now what we need to do is, so using an IAM policy binding, we should say, we should tell the Hello API allow access to the web application. So here you can see we have a receiving service defined as the API and the calling service defined as the web app. Then we say gcloud run services at IAM policy binding for the receiving service using the service account of the calling service. And we also say this is the role on IAM. So now if we execute this, right, so it just created a policy binding. So now let's redeploy the app to refresh the state. So if we go to the build again, go to the trigger, we trigger the Hello World web app. Okay, so it takes some time to refresh permission. Yeah, so now it's good. So now the web app can access the API. So we can also check this via the web app logs. So if we go to the Cloud Run service web app and go to logs. Yeah, so here you can see, so this is the listener start point, and then it's invoking the Hello API, generating a token, and then invoking the Hello API and sending the response back. So this is 4.3. Let me refresh. Yeah. So so it has processed correctly. So yeah, so that's about the last demo. So now if we go back to the presentation, do you have any questions up to now?
I have one question.
Yeah.
So those endpoints exposed by this particular code run, say lambdas or whatever.
Yeah.
So are they accessible by the public internet by default?
Yeah, so it depends on how we deploy the Cloud Run service, Ishan. So yeah, if I show you the, so if we go to the, let me close this, let me close this as well. So if we go to the web app, sorry, yeah, in the Cloud Build YAML, so that we have a parameter to specify whether we should allow unauthenticated access or not. So if we give this parameter, it will allow unauthenticated access. So then it will not be secure. So in this demo, we allow the web app to be accessed directly, but we block the API. So in the API Cloud YAML, we have specified no allow unauthenticated. So then if we go to Cloud Run dashboard and say go to the API and click on the endpoint,
so is it possible to instruct the internal lambda, the Cloud Run, the lambda that we have inside, or the Hello, say the Hello API?
Yeah.
Is it possible to instruct it to not to expose the endpoint to the public API, public internet?
Yes. So that's how we do it. So in the deployment time, we specify this parameter. So then if we say no allow unauthenticated, so it will not, actually it will expose the endpoint, but it will not allow access.
So yes, I mean, I'm asking whether it's possible to, whether it's possible to not expose at all. Maybe, I don't know,
that's a good
like
question.
a VPN.
Yeah. Technically, we should be able to add a firewall and block it.
Cool.
But yeah, I'm not very sure whether on Cloud Run level, we can block it. I didn't see an option yet.
Sure. Thank you.
Thanks, Ishan. Any other questions? Okay, thanks. So let's go back to the presentation. Yeah, can you see my slide? Okay, so so Cloud Run is available in 2 modes. So you can either run the fully managed version, which is completely managed by Google. So you don't need to manage anything. You only pay for the actual usage. Or else, Cloud Run also can be deployed on GKE, on Kubernetes, either on GCP, on GKE, on the cloud itself, or using GKE on-prem via Anthos. So this is how they differ. So if you use the managed version, Cloud Run will run on the Google infrastructure itself without using GCP. So if you run it on GKE, what happens is Cloud Run will run on top of GKE, either on GCP or on GKE on-prem. So what is Knative? So Cloud Run has been built using another project called Knative. So Knative was originally developed, started by Google, and now it's an open source project in Cloud Native Foundation. So Knative provides the main features for implementing a serverless platform. So as you may already know, like Kubernetes doesn't have serverless features. So it's just a container orchestrator. So you can manage containers on Kubernetes, but it doesn't have any other capabilities which are needed for running a serverless platform. So Knative internally use Istio for managing routing and network programming. So it has also built other features for like automatically scaling up and down, and then taking snapshots of deployed code and configurations and so forth. So that's how Cloud Run is implemented using Knative. So Knative at Kubernetes level is like an internal Kubernetes extension. So Knative provides Kubernetes-like manifest. So I'll quickly show you that if you go to the Cloud Run console, so you can see this is the Cloud Run service definition. So here you can see the manifest type kind is service, and it's a Knative service. So this is being deployed on, so in this example, we deployed on fully managed version. If you deploy it on GKE, what happens is this will run on Kubernetes. So this provides all the metadata of the service definition. So you can configure the amount of resources that you need to allocate, the ports, and concurrency level. So here, so each instance handles 80 concurrency, and it will scale up to 1,000. So these parameters you can change. So all these are configured by Knative. So so this is what we already discussed. So basically on Cloud Run, we only pay for the exact CPU memory and number of requests that an application is using. And the granularity of pricing is to the nearest 100 milliseconds of the execution time. So if instance is not processing any requests, we don't have to pay anything. And the way billing works is like when an instance is spawned up, so it will serve multiple requests. So you saw that by default the concurrency is set to 80. So when from the time it take the first request until the time it completes the last request, so that's the time period where the billable time is considered. So then the rest of the time is not billed for the user. So use cases. So you can build either public-facing apps or internal private apps using Cloud Run. So yeah, I think Ishan asked a good question. So if you're building an internal facing app, so you could implement it according to a microservices architecture, have a collection of containers, exposing services, running services listening to async tasks like pubs up topics, schedule tasks, and so forth. And also you can run websites, mobile backends, API endpoints, and webhooks, and many other applications that you can think of, which can be run on containers. So that's about it. So I hope this session was useful. So so we will open up for questions now. So let us know like if you have any questions or any feedback. We'll also share the links to the demos and also slides, so you'll have access to those as well.
Perhaps I'll ask another question. So,
Yes, we can.
So in the first example, you showed an application which is run using Node.js, and then you connect it to a Docker image.
Yeah.
So with respect to the first example, can we use other languages as well?
Yeah, you can. That's because if you closely check how we deployed that, so here what we do is we deploy a container image. So the deployment unit is a container image. So you can basically deploy an app written in any language if you can package into a container image. So therefore, like this cloud serverless service, Cloud Run is not language specific. So it's language neutral. So as long as we can create a container image, we can deploy it on Cloud Run.
Cool.
Yeah. So that's the main difference between App Engine and Cloud Run. So App Engine has a set of specific languages that it supports. So we only provide the code. So then App Engine detects what the language it is written in, and then or we specify it in the app YAML file. So then it will build it using a build pack and then deploy it internally. So here the difference is we do the packaging for the platform.
So another one question.
Yes, Tony.
Yeah, so we are currently using Cloud Run for hosting and GraphQL API.
Okay.
So only problem that we face was that this Cloud Run only support currently for using the Google container registry, right? not an external container registry.
I think so. I need to check that. I'm not very sure.
So we got this question, and we had to set up an external CI to push the image to the Google Cloud Registry.
All right. Okay. So is there any limitations in importing all the required images into the container registry?
No, I think since it's using the Google storage, so only the storage charge will be added.
Okay, right.
I think Chatu, to add to that, there is a Google Manage like a replica of the Docker Hub. I think like most of the images you find in Docker Hub, you can see there. I think you can use that.
Yeah, the problem was, Milindu, we actually using our own CI system previously set up with GitLab. So we were actually building the Docker image in the GitLab itself.
Oh.
Apart from that, all the developer experience was very seamless and very easy to use.
Great, thanks for that feedback, Chatu. I'm sorry, I'm not aware of that, whether it doesn't allow or not. So yeah, since you have already experienced, you may not better. Yeah. Thanks also, Milindu, for your feedback. So the most the key thing about this is so if you're building an app for a small or medium scale business, so it will not cost you when the system is idle or requests are low. So the only place you might need to spend money on maybe for databases. So if they are not serverless, so then for a startup or a medium scale app, so using container images, so you can implement a quite complex application. So previously with serverless functions, the problem was we can only run functions as a unit, right? So it's very hard to implement a complex system. So with this, we can build a fairly complex system on such a container-based serverless platform.
Yeah, even the cost is very low. We only had about 11 cents or something per month.
All right, okay. Yeah, it even has a free tier. So if you're yeah.
And be aware, if you're using a kind of a file transferring inside your container, it also going to be costly because we had an email service.
Okay.
So we had a attachment sending from the client side to the our container to process in the Cloud Run, and later we use an external service to send it. So for that, we got charged for the traffic going out from Singapore to US, where the email service was hosted. So apart from, we later mitigate it using the upload into the external service.
All right, okay. So the charge was for the network bandwidth or for the file service?
For the network bandwidth.
All right. So yeah. So by the way, I'm not from the Cloud Run team. So if you have any questions, any technical, any other problems, so we can coordinate you with the team. So if you want to get more information. So yeah. And thanks a lot for attending. And thanks a lot for Shafraz for inviting me to conduct a session, and also Pamudita and Tarak for coordinating this. And thank you everyone for joining. So if you guys don't have anything else, so we can wind up the session. What do you think, Pamudita?
Yeah, we can wind up.
Okay, then thank you very much, everyone. So we'll meet again at another event.
Yeah, sure. Thank you, Imesh, for the content and the time you put up toward this.
It's a great pleasure. Thanks a lot for attending.
Thanks, Imesh.
Thank you.
Thank you.
Thank you. Good night.
Thanks, guys.